It's from here, the island of Sriharikota near Madras, nowadays called Chennai, in the Bay of Bengal, that India launches its satellites using its own launchers. At the Vehicle Assembly Building, the Indian PSLV is almost ready and awaits its passenger for what is an important first for India, a mission to the moon. Here is Chandrayan, the Indian lunar craft under preparation in Bangalore. Chandrayan means journey to the moon in Hindi. India has already built and launched many satellites, but this is the first time that it will venture beyond Earth's orbit.
Chandrayan is a very major milestone as far as the Indian space program is concerned. It has been the dream of the Indian scientists to send a satellite around moon and then collect more data about the surface features, minerals and so on. That dream is going to come true through this mission, which is expected to take off shortly.
To ensure a successful lunar mission, India has had to show expertise in various fields. Indian engineers have put in place everything needed to send a spacecraft around the moon and develop the technology to study the Earth's natural satellite. For India, Chandrayan represents a scientific and technological challenge.
The challenge is basically we are sending the satellite from here to 400,000 kilometers away. So it's quite far off. So we have to make sure our trajectory is correct and the angle or the orientation is correct and the timing is correct. When we reach the moon, moon must be at the exact place as we designed. So we make sure our guidance and control, the propulsion system, the communication system, everything is in place perfectly.
On its own, the Chandrayan spacecraft is not enough. An entire ground network is needed to monitor and control it, sending commands and receiving data. So, about 30 kilometers outside Bangalore, the Indian Space Agency has built a tracking station which includes a 32-meter antenna, the heart of India's future deep space network. This antenna, linked with a number of other centers, will pick up measurements from various instruments on board Chandrayan, enabling the scientific community to study the moon remotely. It's a technological feat, but Chandrayan will also differ from earlier lunar missions in offering complete lunar mapping.
We are going to look at the moon slightly differently than the people have looked at, are looking at. That is, we have looking at the moon very, very systematically. Take the whole moon, systematically take the whole moon's pictures, both for the mapping, chemical mapping, mineral mapping is concerned. We want to make a repository of the whole moon, what moon contains.
One of the important aspects of Chandrayan is its international character. Of the 10 or so research instruments on board, 6 are the result of cooperative efforts, including 3 with the European Space Agency. For Europe, this is an extra opportunity to go into space, as missions are rare. In addition, the 2-year flight around the moon should provide new data to complement that gained on previous missions.
Apollo has been a very long time ago, and instrumentation has really significantly changed since then. Another important feature of the Chandrayan mission is that it goes very close to the moon. It goes to a circular orbit of 100 kilometers, which allows imaging of very detailed nature. The Apollo missions, yes, they went down to the surface, but only in a limited number of spots, whereas Chandrayan tries to do detailed imaging of the entire sphere of the moon.
For the European Space Agency, Chandrayan also represents an opportunity to reuse improved versions of the instruments that studied the moon on its Smart 1 mission. It's also a chance to send new instruments that will be used in upcoming ESA missions, such as the Bepi-Colombo mission to Mercury. With this lunar mission, India is sending out a clear message about its independence and its ambitions. The Indian Space Agency has already announced further missions to the moon and beyond.